Hello everyone. So today we will be discussing what many people consider by far the most confusing part of theory of equations, that is location of roots when it comes to quadratic equations. This is again one of those parts of JE theory that do not actually require much memorization, but instead it will test your graphical skills, your skills to understand how different functions are graphed. In this case, how quadratic functions are graphed. And if you think about it, there isn't much to remember, but there is much to analyze. So we will be starting right from the basics and we will be covering it in two parts. This is the first video in which we will take 5 cases. The next video will consist of one case and then two previous year questions that JEE has specifically asked on location of roots. As I said, we will start from the very basics and move on to the advanced level. So even if you feel that you are not confident about this chapter, you can still watch this video. Now, before starting, let us first consider a general case of how a quadratic equation looks when we plot it graphically. So let us say that we have an equation ax square plus bx plus c, and in this case let us assume a is greater than 0. There are many possible cases in which how a graph can look. Either when we say that we have d greater than 0, that is it has two distinct roots, it can look something like this, or it can look something like this, or it can look something like this. Similarly, when d is exactly equal to 0, we have cases of equal roots. So both roots will lie at the same point. And when we have d less than 0, which is imaginary roots, graph will completely lie above. So this is just a general understanding. A can be less than 0, then the graph can change here and there. So just a basic idea of how to visualize graph of any quadratic equation. This is a parabola. If you've studied parabola, you will be able to realize it. But even if you have not, as most people have not when they first study quadratic equations, it's okay. The minimum point, this is called the vertex. The very edge of a parabola, it is always given by minus b by 2a, comma. The x coordinate is minus b by 2a, comma. The y coordinate is minus d by 4a, where d is the discriminant, that is b square minus 4ac. Now, even if you know this, even then you can understand a lot many points about the graph of a quadratic equation. Let's say a is greater than 0, right? So in case of imaginary roots, d is always less than 0. So this is greater than 0, this is less than 0, plus we have another minus sign. So overall, y will be positive. That is why graph is always above x-axis. In any case, let us take the cases one by one. The first case is when both roots are greater than k. K is any constant. Okay, let alpha and beta be the roots. For a greater than 0 and for a less than 0, we will have two graphs, a greater than 0, d greater than 0, and d is equal to 0. Similarly, d greater than 0, d is equal to 0. And as I said, in general, represents a curve with vertex this. Now, focus on k. Now, f of k is the value the graph or the equation will assume when you will put k in this equation. So a k square plus b k plus c is the value of f of k. In this case, you can see that it is positive, right? And when a is less than 0, f of k will be negative. This is the value, it is negative. Here it is negative, here it is negative. Similarly, here you have positive value, here you have positive value. Again, this is all about visualization. This is a constant k. Both roots are greater than k. So they will lie to the right side of k. Hai na? Till here we have done nothing. We have just graphed the four possibilities that can happen. So first thing we have realized that when a greater than 0, f of k is greater than 0. When a is less than 0, f of k is less than 0. So combining this, when we multiply this, we will get, since these are both positive, this is positive. Since these are both negative, this is again positive. So in either case, a times f of k will be greater than 0. So this is the first condition. But this is not the sufficient condition, because you can see that the converse isn't true. For example, if a of f of k is greater than 0, roots can also lie to the left of k. So see, in this case, again, a is greater than 0, f of k is also greater than 0, but roots are lying to the left of k. Therefore, both roots are not greater than k, they will be less than k. So that's a different case. So we need to add an additional condition. What? The x coordinate of the vertex, that is minus b by 2a. It has to be greater than k. So when minus b by 2a is greater than k, see, in all these cases you will see minus b by 2a is greater than k. Only then we can say that the graph is satisfying the conditions of both roots are greater than k. Okay, till here are you with me? We have seen two cases. First, a into f of k should be greater than 0, and next, or minus b by 2a should be greater than k. So we have two conditions. However, Again, there can be a possibility. See, in this case, a is greater than 0, f of k is greater than 0, and minus b by 2a is also greater than k. However, here we have imaginary roots. Imaginary roots, you cannot say, right, that an imaginary number cannot be greater than a real number. You cannot compare it that way. If you have studied complex number, you can never say that minus 5 by 3 iota is greater than, let's say, 19. Makes no sense. Its magnitude can be less than 19, but directly you cannot compare. This is a meaningless thing. In any case, if you have not studied complex numbers, you will realize it then. But you have to remember it that unless and until there are roots, real roots, how can you say if it is greater than k or less than k, right? So the equation must have real roots also. This is the third condition. Don't worry, this is the only case the conditions are a little lengthy. It is taken as a first case because you will realize how to visualize a graph and how conditions can come about. And the best part is you do not actually need to remember all these things. You can just visualize it in exams, but it is advisable to remember them because sometimes you can make mistakes. You can forget certain conditions. Like here, it is possible that you will make a mistake, that you will forget this case or you will forget this condition. So the answer can go haywire. Combining all this, we get three conditions and so it is an intersection, it is not a union. The first thing is a into f of k has to be greater than 0 and minus b by 2a has to be greater than 0 and d has to be greater than equal to 0. When you have these three conditions, both roots will be greater than k. So don't worry, all the cases will not have these many conditions. And I've explained this, and again, you can visualize this if your visualization skills are strong, if your graphical skills are strong, which you can easily do it by enough practice. You will be able to derive this or you will be able to formulate this on the exam day itself. But it's better to remember so that you do not miss a case. So it should not be that you miss one of these conditions. Okay, then your answer will be wrong because we have to intersect all these three. Similarly, when both roots are less than k, it is exact similar case to the previous one, but here, minus b by 2a has to be less than k because the vertex has to lie to the left of k. Exact same reasoning as previous one, but only the change in condition is this one. So I hope you will be able to figure it out. Now, the next case is roots are lying on the either side of k. What it means is that k, this does not mean that k is the vertex, okay? K can be anything, k can be here also. But both roots, that is alpha and beta, are on either side of k. So again, we have two cases, a is greater than 0 or a is less than 0. Now look at this graph, okay? When a is greater than 0 and both roots have to lie on either side of k, f of k will always be negative. Wherever you put k, the value of f of k, that is the value of graph at x is equal to k, is always negative. So when a is greater than 0, f of k is always less than 0. Similarly, when a is less than 0, f of k will always be positive. That is simply how graphs are made when it comes to quadratic equation, right? You can visualize it. There cannot be a graph in this case where f of k will be less than 0. So when a is less than 0, f of k is greater than 0. So finally, so in this case, this is positive, this is negative. So it will be a into f of k will be less than 0. Similarly, in this case, a is negative, f of k is positive. So in either case, when you multiply a into f of k, the total value will come out as negative. Now, the beauty of this case is this case automatically ensures that the graph crosses the x-axis. Why? Let's say you have imaginary roots. Let's say you have a case like this, okay? Or let's say you have equal roots. Okay, this is equal. Here, it doesn't make sense to have k if there is no alpha and beta. If there is no real alpha and beta, you cannot even compare k. That's the first case, okay? And even if there is a k, then you cannot have equality because alpha and beta are both equal. So this case does not make sense. So in any case, this too cannot be a possibility when roots are lying on either side of k. Therefore, d by definition has to be greater than 0. That is the discriminant. That is, it will have two distinct roots. Only then this will make sense, right? Alpha less than k less than beta. So this is the only necessary and sufficient condition for both roots to lie on either side of k. So this is our third case, only a single condition. Now, a special case can be when an equation says that the roots are of opposite signs. So what this means that one root is positive and other root is negative. This means that 0, k is 0 lies somewhere in between this graph. Only then we can say that one root is positive and one root is negative, right? So 0 comma 0. So in this case, f of k into a has to be less than 0. Again, we are just putting f of 0 in this here because If one root is negative, one root is positive, 0, that is origin will lie in between those two roots, right? So in special case, if both roots are of opposite signs, this is the necessary and sufficient condition. And how we have figured it out? Simply putting k is equal to 0 here. So we will get a into f of k is less than 0. I hope you have understood this case. The next thing is exactly one root in the interval k1 and k2. So again, we will visualize it using graphs. When a is greater than 0, we have two cases. When a is less than 0, we have two cases. It's not a case, it's not sub case, okay? It's just I have visualized it. The conditions will come out to be a single condition, but it is just helpful to visualize it. It is not that you have to remember all of these, like case 4 we have four sub cases, and case 1 we have four sub cases. It is not like that. So it can look a little lengthy, but when I'll summarize it, it will fall into place very quickly and it will be very short. So don't get overwhelmed. So exactly one root in the interval k1 and k2. Again, visualize this graph. Let us say a is greater than 0. So k1 here, k2 here, or k1 here, k2 here. Similarly, K1 here, K2 here, K1 here, K2 here. These are the only cases that are possible. Now, in any case, if f of K1 is positive, f of K2 is negative. If f of K1 is negative, f of K2 has to be positive. Similarly here, so f of K1 into f of K2 both has to be less than 0 because both are always of opposite signs in any case. And similar to how we said d has to be always greater than 0 in this case. You cannot have imaginary roots, because if there's an imaginary root, it does not make sense that where does this root lie. This is not, because in this case you cannot say that okay, there is only exactly one root that is lying here. There's no root that is lying here. It's imaginary roots. You cannot compare real and imaginary quantities, because also you have only one condition, necessary and sufficient. Finally, we have the fifth case. For this video, this is the final case where both roots lie in the interval k1, k2. Four possibilities, which are basically the same, but again, four, just to visualize it, a is greater than 0, 2, a is less than 0, 2 cases. Now see, when a is greater than 0, either k1 and k2, f of k1 and f of k2 both have to be positive. That is how the graph is. Both roots lie, because both roots have to lie into interval k1 and k2. If a is greater than 0, the graph will have two possibilities. If k is less than 0, the graph will have two possibilities. And in either case, when you multiply a by f of k, so this is easy, this is all positive. So this makes sense. A into f of k1 is greater than 0, a into f of k2 is greater than 0. But when a is less than 0, f of k1, f of k2, in every case, in both the cases, they are less than 0. So a into f of k1, because this is negative, this is also negative, this will be positive. This is negative, these are also negative, so this will be positive. And similar to the case we saw previously, minus b by 2a now has to lie in between k1 and k2. This is the case I was talking about, right? There, minus b by 2a had to be greater than k. In this case, minus b by 2a has to lie between k1 and k2. And finally, d has to be greater than or equal to 0. Again, similar to previous cases, it does not make any sense when roots are imaginary to have any comparison between real quantities and imaginary quantities. So overall, we have seen 5 cases today. What I'll advise you is to make notes of all these conditions. So just write it as case 1, both roots are greater than k. We have these three conditions. Okay, that will be our first point number 1. Then when both roots are smaller than k, these three conditions, that will be a point number 2. Roots lying on either side of k, a into f of k less than 0, that will be a third case. If you want to mention a special case, you can write it, but you can just remember it, right? You don't have to do anything, just substitute k is equal to 0 here, and then you will get roots are of opposite signs. Fourth point would be exactly one root in the interval k1 and k2. This will be the necessary and sufficient condition. Fifth would be both roots in the interval k1 and k2, and these will be the necessary and sufficient conditions. So this is how you can make notes. But I'm again advising you, remember why these points came about. Because memorizing is one thing, but you also have to understand them, okay? You cannot just memorize everything. So tune in for the next video where we will the next case as well as two previous year questions that are based directly on location of roots, JEE advanced questions or IIT JEE questions. Thank you.